Namaskar, my dear friends. Let us talk about what are the different parameters that we need to take into account before selecting an IGBT. So, as we have already seen, what is IGBT, what are their features, and how they are utilized in our different applications in basically inverters and automotives and all. So, this is the IGBT symbol that is there, and this is one of the like a TO247, TO247 or 247 package that looks like. Okay. So let me list out some of the few parameters that you need to consider before selecting a particular component for your application. So let us say, first of all, we will be talking about voltage rating. Okay. Voltage rating. So this is nothing but voltage across your uh, collector to emitter. Basically collector to emitter, what is the maximum voltage that can be applied. So let us say one of the parameter can be 650 volt. So it can vary, let us say from 400 volt to around, 2000 volt. Basically in general applications, you will be seeing like 600 volts are more than enough, or 650 volts, or even 1000 volts, or even to 1200 volts. So these are few values that are predominantly used. Okay. Now coming back to second parameter, which is current rating. Current rating. So what is the current rating that you are looking for? That is nothing but your collector current. Like basically when it is in saturation mode, what will be the current that will be flowing through collector to emitter. Okay. So what is that? Let us say, for example, I will tell you like 40 ampere rating or 80 ampere rating or maybe 100 ampere rating. So all these parameters we can have a look into that. Okay. Similar to that, few more parameters we can list out. Let us say what is the saturation voltage drop across collector to emitter. Okay. So like we collector to emitter at saturation level. So it has to be as low as possible. That is the better, like 1.6 volt or 1.7 volt or maybe 2.1 volt or something like that. So how much do you want a power dissipation? Higher the voltage drop across collector to emitter, higher the power dissipation will be there. Okay. Similar to that, we have power dissipation capability. Okay, so power dissipation. So in power dissipation, basically it is PD. So it can be, like ranging from, let us say, 144 watt or maybe 220 watt. It depends on, like what is the functionalities or what is the capability of the IGBT that you are choosing ahead, right? So 214 watt or something. So it depends on, let us say, your power consumption is around, let us say, 20 watt. So you can go ahead and choose a IGBT of 100 watt capability. Okay. But that you have to manage, that you have to understand that it has to be in nominal operation. Otherwise you will be losing lot of opportunity in performance. Okay. Good. So these are the things. Now coming back to next parameters, we can talk about applications. Okay. So what are the different applications that this particular IGBT has been, targeted to, like whether it is in automotive applications or like on-off chargers, like basically, automotive, then like on-off chargers, or like electric vehicles and all, we have DC-DC converters. Okay. There are several, like applications that we have these days. What else we can list out? We can list out, like PFCs. Lot of, like applications are there in PFCs these days. Then we have, like industrial inverters. We have IH, like induction heating and all. Okay. So in pressure cooker or something like that, we try to utilize this. Good. So these were the things. Now we talk about, like sometimes not only continuous current rating, we can talk about pulse collector current rating. Okay. Pulsed collector current rating. So pulse collector current will be little bit higher than the continuous current. So that can be defined as IC P, so collector pulse current. It can be little bit higher. Let's say if your current rating you have chosen for 80 ampere, then it can go ahead as high as, let us say, 160 ampere or something like that, twice of that maybe. Then of course we have to have operating temperature range. Temperature range. So what is the temperature range the IC can work on? Let us say it can work on from, let us say, minus 40 degrees centigrade to 175 degrees centigrade or something like that. Okay. So this is one of the, like best or one of the important parameter that we need to take care of. Coming back to other parameters, we can think of is thermal resistances. Okay. Thermal resistances. So lower the thermal resistance, high better the value. Like basically it can be thermal resistance IGBT junction 2 case. So junction 2 case is represented as R theta JC. Okay, so R theta JC can be 0.7 degree centigrade per watt. So 0.7 degree centigrade will be increment for 1 watt of power dissipation across this. Okay, similar to that we have other parameters like what is your get to emitter threshold. Okay, so get to emitter threshold voltage, get emitter threshold voltage. If you have get emitter threshold voltage lower, it is better because it can be easily switched on. Understood? Higher the gate threshold voltage, higher the power dissipation or something like that is also there sometimes. So you can see it can be varied from, let us say, 4 volt or 5 volt or 6 volt, something like that. It is in the range of 4 volt to around 8 volts or something. Okay. Then as we have already talked about what is the collector and emitter saturation voltage, that is around like 1.5 volt or something. So that's not a problem. Some other parameters are like input capacitances and output capacitances. Okay, so input capacitances like CIES, that is input capacitance. It can be in the form of like picofarads. Then output capacitances COES, that is in also picofarad or it can go into nanofarads as well. Then the most important parameter that you have to look into before selecting a IGBT is the gate charges. Okay, gate charges. So gate charges can be in the form of two charges. One will be like gate emitter charge, that is QZ to E. Okay, so gate to emitter charges, and another will be collector charges. Okay, so QZC. Understood? So basically gate charges will be represented as QZ, and gate to emitter will be another one, and one more will be gate to collector charges. The other parameter that you have, these will be in terms of like nanocoulombs. So nanocoulombs will be there around like, let us say, 40 nanocoulomb or something less than that, around 22 nanocoulomb or something like that, for a general MOSFET that I am general IGBT that I am talking about. Now the very important parameter, however, this parameter depends on your temperature. Okay, however, this is very important. Why? Because what is your turn on delay time? Okay, so let us say what is your turn on delay time. So this can be also represented as TD on. So TD on, TD off, like that, delay time. Similar to that, turn off delay time. Okay, turn off delay time, TD off. So what is the turn on time? What is the turn off time? Similar to that, during turn on there will be an rise time. So like what is my rise time? Okay, so that is also called as TR. Then what is my fall time? Fall time. This will be called as TF. So basically you will see turn on time and rise time will be little lesser compared to turn off time and fall time. Understood? And these four parameters will depend on the temperature, like whether it is let's say 25 degrees centigrade, the parameter can be different, and 175 degrees centigrade the parameter will be little bit higher. Okay, so this has to be taken into account while selecting your IGBT. Then other parameters is very important because of like efficiency and all. So what happens is this is also called as switching losses. Okay, so switching losses, switching loss. So this can be of two types. One will be turn on switching losses. What is that? What is the loss during turn on? Turn on switching losses, and then turn off switching losses. Okay, so turn on switching loss can be little bit like lower compared to turn off, because turn off it takes little bit longer time to turn off. It can be in millijoules, let us say 0.27 millijoule, or let us say this one is 0.51 millijoule. So I can take up like one of the data sheet to get these values. Then you must consider what is the safe operating area of your MOSFET, of your IGBT. Okay, so reverse bias safe operating area, reverse bias safe operating area. You had seen in my previous videos, like during the like showcase of your performance characteristics. In that case, we had already shown you like what is the safe operating area, what is the charge. So these are the few parameters that you need to take into account before selecting an IGBT. And of course, there are few parameters which is very easy to understand for anybody. Like the IGBT is RoHS compliant, and then it can be like it is having high longevity or good longevity, like active status. The IC must be active, good longevity. Good longevity means like it will be there in the market quite longer time. If you are selecting that, IC should be active, right? Then other parameters can be like a very important parameter, which is going to be a package. So package generally for IGBT, if you are going ahead, you can always go ahead TO220 packages or TO247 packages. Okay, so these are the packages that you can go ahead for high end applications, like we have a railway application and all. Then there we have little bit different package which is of little bit bigger size. Okay, so good. I hope you have now a good understanding of what are the different parameters that we need to take into account, and few more parameters if you want to put it. You can always take into account, like what is your what is your input type. Input type, generally if it is a standard inputs, like like a 230 volt AC, that is going to get converted into DC. Okay, so this is how you will be getting around 325 volt or something like that as DC voltage. Okay, so it has to be like, let us say, standard type. A standard type basically are two types, like one is 110 volt AC, then this will get rectified to give you 110 root 2 volt DC. Okay, similar to that we have 230 volt AC, that is in utilized in India. So you will be getting 230 root 2 volt DC. So this is how a standard type inputs that can be utilized. All right, guys, and of course, like few more parameters that you always look into is like let us say manufacturer. So basically, a few manufacturers are recommended. Like you can always go ahead with onsemi. Onsemi is one of the like a leading manufacturer for IGBTs. Then we have Infineon. You can also take on like a Rome Semiconductor. Even you can take it from Toshiba. Okay, I hope my spelling is right. So Toshiba is also one of the like a best manufacturer for IGBTs. Alright guys, so hope you have a good understanding now what are the different parameters that you need to take into account before selecting a IGBT. So you can take into account all these parameters one by one. I'm just like taking one by one again so that you can always recall it. Okay, so temperature and all is there, then we have applications, then we have this particular power dissipation and everything. So good, hope you have now like enjoyed this particular session and you have an understanding of selecting IGBT for using different parameters that I have listed out here. Okay, thank you.